Hello there. This is just a quick review of real numbers. From your studies of math so far, you would recall that real numbers are made up of whole numbers, the counting numbers 0, 1, 2, 3, 4, 5, and so on. It also has negative whole numbers, which are the negative counterparts of the whole numbers negative 1, negative 2, negative 3, negative 4, negative 5, and so on. And then you also have the positive and negative fractions, which you call rational numbers. And examples of rational numbers are negative 2/3, which is a recurring decimal. You will remember that you can write it as negative 0.6 bar, which means it's negative 0.6666666. You can approximate as negative 0.67. 1/2 is another fraction, 0.5, and 3/5 is another example of a fraction, 0.6. There are infinitely many of them. And then you have these other types of numbers, which are irrational numbers. These are the numbers that you cannot write as fractions. You cannot write them as one number divided by another number, another whole number. And you can only express them either as special characters, special symbols, or as non-terminating and non-repeating decimals. You have probably heard of the number pi. That's a good example of an irrational number. It goes on for as much as 1,000,000 decimal places that do not repeat. And you also have the Euler number e, which is also another example. It behaves like the number pi. It goes on, for like lots and lots and lots of decimal places. It will not terminate and it will not repeat. You also have a group of numbers that you can form on the real number line, the square root of prime numbers. Now, what's a prime number? A prime number is a whole number that has only two divisors, itself and 1. What do we mean by divisors? Here's what it means. A divisor is a number that can divide another number without leaving a remainder. For instance, 3 is a divisor of 6 because when you divide 6 by 3, you get 2 without a remainder. 2 is also a divisor of 6 because when you divide 6 by 2, you get 3 without a remainder. 5 is also a divisor of 30 because when you divide 30 by 5, you get 6 and there is no remainder as well. Now a quick question here. How many divisors does 6 have? If we want to figure out if a number is prime, we just think about how many divisors it has. So like 6, for instance. How many divisors does it have? Well, 6 divided by 6 is 1. 6 divided by 2 is 3. 6 divided by 3 is 2. And 6 divided by 1 is 6. So that means that 6 has 4 divisors. 1, 2, 3, and 6. Because 6 has 4 divisors, it is not a prime number. Remember we said a prime number is a number with only 2 divisors, itself and 1. And by the way, the things we call divisors, you can also call them factors. Okay, that's why I'm calling these factors in here. So you say that 1, 2, 3, and 6 are factors of 6. What about 20? How many factors does 20 have? We can do the same thing we just did with the number 6. And we will see that 20 has a number of factors. It's 1, 2, 4, 5, 10, and 20 are all factors of 20. Because 20 has more than 2 factors or 2 divisors, you will see that 20 is not a prime number. Similarly, 9 is not a prime number because it has more than 2 factors, 1, 3, and 9. But what about the number 2? How many factors does 2 have? 2 has only 2 factors, itself and 1. If you divide 2 by 1, you get 2. If you divide 2 by itself, you get 1. There's nothing else that will divide 2 and give you a whole number without a remainder. So therefore, 2 is a prime number. Another example of a prime number is number 3. 3 is a prime number because it has only 2 factors, itself and 1. Similarly, 5, 7, 11, 13, 17, and 19 are all prime numbers. They have 2 divisors each, themselves and 1. So why don't you try and name a few other prime numbers? Perhaps you can come up with a few yourself. Now, the reason why we talked about prime numbers is because we were trying to describe another group of irrational numbers on the real number line. The square root of prime numbers are irrational numbers. So all those numbers that have only 2 divisors, themselves and 1, if you take their square root, you will get irrational numbers. But what do we mean by square root? The symbol for a square root is what we have in here. When you see that symbol, it means you are taking the square root of whatever is inside that symbol that we just written down. And it's the square root of a number is another number that is non-negative, such that when you multiply this number by itself, you will get the original number you're taking the square root of. For example, the square root of 4 is 2. 2 is non-negative, and 2 times 2 is 4. Therefore, the square root of 4 is 2. Similarly, the square root of 9 is 3, because 3 times 3 is 9, and 3 is a non-negative number. On the other hand, you will remember that negative 3 times negative 3 is also 9. But the square root of 9 is not negative 3, because by definition, the square root of a number has to be non-negative. Okay, so that's why the square root of 9 is not negative 3. But what about the square root of 2? The square root of 2 is not a whole number. See, it looks like pi or e, the Euler number. It's a non-terminating and non-repeating decimal. Okay, so the square root of 2 will be a number such as these. It's an irrational number. Same thing for the square root of 3. It will be a number that behaves like pi. It's a non-terminating and non-repeating decimals. So we don't have to write the prime numbers, in their decimal form all the time. We can just write them as square roots of the prime numbers, like the square root of 2, the square root of 3, the square root of 5, 7, square root of 11, square root of 17, and so on. Then since we have identified the real numbers now, we can place them on the real number line. So the real number line extends, from left to right. To the right, you have positive numbers, and to the left, you have negative numbers. You can start on the real number line by identifying whole numbers, 0, 1, 2, 3, 4, and so on to the right, negative 1, negative 2, negative 3, negative 4, and so on to the left. And then we have the rational numbers. Those are the numbers that fall between the whole numbers. They are the fractions. You can write them as one whole number divided by another whole number, like negative 2/3. Which is negative 0.67. We identified that earlier. 1/2, which is 0.5. Or you can talk about 2.75, 2 3/4. Okay, that would be another rational number on the real number line. And then finally, we have the irrational numbers that we have been talking about, like pi. We can approximate as 3.14, square root of 2, the Euler number, square root of 3. You can also talk about their negative counterparts, negative root 2 and negative root 3 on the real number line. So, maybe you want to try and identify some real numbers on the real number line. What you may want to do now is to pause this recording and try to fill in the real number line by yourself, and then after you're done, you can continue the video and then try to see what I have done in this example. So go ahead and pause the video now. So what did you do? Well, here's what I did. On the real number line, you can put the whole numbers on it, and then you can have 0 in there. 0 is one of the numbers we're supposed to identify on the real number line, and you can fit in the rational numbers, as I've done there, and also you can put in the irrational numbers with the approximate values in decimal on the real number line. So this concludes the quick review of real numbers and the real number line.